Okay, this is number 6 in the PDF file under Relative Extrema, and you can find that at mathcoverage.com if you click on the link Calculus at the top, and it'll take you to the page, and click on the topic Relative Extrema and bring up the PDF file, and you'll see this particular problem. Anyway, they're asking us to find the relative extrema, and we have f of x equal -5 minus x to the 2/5. Now I've got this kind of a rough sketch here, kind of graphed out for us, kind of give us an idea of what this graph looks like, even though it's best not to get used to looking at graphs, right? We want to trust the math, and so we can see the graph here, and this kind of fat blue dot here really shouldn't be here. Need to kind of trim that thing down a little bit. Okay, there you go. Anyhow, right. And so we can see at the graph here that this graph from -infinity to 0 is increasing. And then it starts decreasing from 0 to infinity. And we're going to show that by taking the derivative of f of x, and that means derivative of constant 0, and bring the 2/5 out front, subtracting 1 from 2/5. I do the side work over here. We get to -3/5. Bringing this back down into the bottom. Now we need to find the solutions to this equation. Well, there aren't any solutions, but we have a fraction here. We also need to look at the bottom, what makes the bottom 0. And the only thing we can plug in the bottom to make this 0, and that's 0 itself. And the question is that a critical number? Because remember, on our number line here, we're only concerned about plotting down critical numbers. To see if it's a critical number, this here must be in the domain of the original function. Okay, let's see. I had to pause that for a second and take a moment's break. But anyway, if you take 0 and you plug it back into the f of x, and if that 0 is in the domain of the original function, then we can consider it a critical number. So I draw the number line, I plot my 0, which is my critical number, and then I take my test points, which has to be -1 and 1, which I'm circling here. These are my test point. So you take your test points and plug them to the derivative. -1 raised to the 3/5 is -1, and we have a minus out here, so that's going to be a negative, and a negative is positive, so you get a positive number. So I put a plus sign here, and then I draw an orange line indicating that if you plugged any number to the left of 0 in, the tangent line is going to have positive slope. So this is just kind of representing a tangent line here. Doing the same thing with 1, plugging it into the derivative, we get a negative number out, and so I minus sign there, and then indicate that with this orange line that's a slope of this orange line is decreasing. So anyway, and this is kind of a useful thing because it gives us an idea of what this graph is doing. And of course, if we look at the graph, we see that it's increasing and then decreasing, and you can graph this on a graphing calculator to get a visual on that. So the next thing we're going to do is actually find that point, and that is we want to take our critical number, plug it back into the original function, that is our f of x, plug it in, and -5 minus 0, that's 0 to the 2/5 is 0, is equal to -5. So we say then that 0, -5 is going to be a maximum, and I'll just kind of sketch that out right there. And that concludes this problem.